NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math lesson on monomials. Today, we'll explore three key concepts related to monomials: numeric coefficients, total degree, and degree with respect to a variable. Let's start with the basics. A monomial is an algebraic expression that consists of a number multiplied by variables raised to non-negative integer powers. For example, terms like 5x cubed, y squared, negative 2a to the fourth power b, and 7z are all monomials. Now let's discuss our first concept, the numeric coefficient of a monomial. The numeric coefficient is the numerical factor in the monomial. For example, in the monomial 5x cubed, y squared, the numeric coefficient is 5. In negative 2a to the fourth power b, the coefficient is negative 2. And in 7z, the coefficient is 7. Our second concept is the total degree of a monomial. The total degree is the sum of all the exponents of variables in the monomial. Let's look at our examples again. In 5x cubed y squared, the total degree is 3 plus 2, which equals 5. For negative 2a to the fourth power b, the exponents are 4 for a and 1 for b, since b to the first power is just written as b, so the total degree is 4 plus 1, which equals 5. For 7z, the exponent of z is 1, so the total degree is just 1. Our third concept is the degree with respect to a specific variable. The degree with respect to a particular variable is simply the exponent of that variable in the monomial. If the variable doesn't appear, its degree is 0. In 5x cubed y squared, the degree with respect to x is 3, and the degree with respect to y is 2. The degree with respect to z is 0, since z doesn't appear in this monomial. In negative 2a to the fourth power b, the degree with respect to is 4, and the degree with respect to b is 1. Let's try a more complex example. Consider the monomial negative 3x squared y cubed z to the fourth power. The coefficient is negative 3. The total degree is the sum of all exponents, 2 plus 3 plus 4, which equals 9. The degree with respect to x is 2, the degree with respect to y is 3, and the degree with respect to z is 4. Why are these concepts important? Understanding the degree of a monomial helps us classify and manipulate algebraic expressions. For instance, when we add monomials of the same degree with the same variables, we get polynomials. Knowledge of coefficients and degrees is essential for operations like multiplication and division of algebraic expressions. These concepts are widely used in calculus, physics, engineering, and computer science. Let's summarize what we've learned today. We've covered three important concepts related to monomials. First, the numeric coefficient, which is the numerical factor of the monomial. Second, the total degree, which is the sum of all variable exponents. And third, the degree with respect to a specific variable, which is the exponent of that variable in the monomial. Welcome to this math lesson on analyzing algebraic expressions. Today, we'll learn how to identify the type of an expression and determine the coefficient and degree of each variable. Let's dive into an example. We're given the expression 4ab squared, and we need to determine if it's a monomial, find its coefficient, and find the degree of each variable. Before we begin, let's clarify what a monomial is. A monomial is a single term that consists of numbers, variables, or a product of numbers and variables with non-negative integer exponents. Let's start by determining if 4ab squared is a monomial. A monomial has exactly one term, with no addition, subtraction, division, or negative exponents. The next step is to identify the coefficient of the monomial. The coefficient is the numerical factor that multiplies the variables. In our expression, for ab squared, the coefficient is 4. Now, let's find the degree of the variable a. The degree of a variable is the exponent of that variable in the expression. In our monomial, for ab squared, the variable a has an exponent of 1, which is typically not written, so the degree of a is 1. Next, we need to find the degree of the variable b. In our monomial, the variable b has an explicit exponent of 2, so the degree of b is 2. Finally, let's find the total degree of the monomial. The total degree is the sum of all the variable exponents. We have a to the power of 1 and b to the power of 2. So, the total degree is 1 plus 2, which equals 3. Let's summarize what we've learned about the expression 4ab squared. First, we determined it's a monomial since it consists of a single term. Second, we identified the coefficient as 4. Third, we found that the degree of A is 1 and the degree of B is 2. Finally, we calculated the total degree as 3, which is the sum of all variable exponents. Understanding how to analyze algebraic terms is fundamental to algebra and will help you work with more complex expressions and equations in the future. Welcome to this math tutorial. Today, we'll learn about algebraic terms, specifically how to identify monomials and determine the coefficient and degree of variables. Let's look at an example. We need to determine whether the following expression is a monomial and identify the coefficient and degree of each variable. First, let's understand what a monomial is. A monomial is a product of numbers and variables with non-negative integer exponents. Examples of monomials include 5x, 3xy, 7x superscript 2, y superscript 3, and so on. However, if an expression contains division by a variable or negative exponents, it is not a monomial. Now, let's analyze our expression. We have 2x in the numerator divided by y times z in the denominator. We can rewrite this as 2x multiplied by y to the power of -1 multiplied by z to the power of -1. Looking at our rewritten expression, we can see that it contains negative exponents for the variables y and z. According to our definition, a monomial must have non-negative integer exponents for all variables. Therefore, this expression is not a monomial. Now, let's identify the coefficient and the degree of each variable in our expression. The coefficient of our expression is 2. The degree of x is 1, because x appears to the first power. The degree of y is -1, because y appears in the denominator to the first power. Similarly, the degree of z is also -1. Let's summarize our findings. The expression is not a monomial because it contains variables with negative exponents. The coefficient is 2. The degree of x is 1. The degrees of y and z are both -1. Quick challenge. Can you identify whether 3x superscript 2y is a monomial and determine its coefficient and the degree of each variable? Pause the video to work it out before we continue. 3x superscript 2y is a monomial and determine its coefficient and the degree of each variable. Pause the video to work it out before we continue. The solution to our challenge. Yes, 3x superscript 2y is a monomial because it's a product of a number and variables with positive integer exponents. The coefficient is 3. The degree of x is 2. The degree of y is 4. The total degree of this monomial is 2 plus 4 is equal to 6. I hope this video helped you understand how to identify monomials and determine the coefficient and degree of variables. Remember, a monomial must have non-negative integer exponents for all variables. Thanks for watching. A monomial must have non-negative integer exponents for all variables. Thanks for watching. We'll determine whether an expression is a monomial and find the coefficients and degrees with respect to each variable. Let's start with an example. We'll examine the expression 4x squared times the square root of y. First, let's rewrite this expression in a standard form using exponent notation. The square root of y can be written as y raised to the power of 1/2. Now, let's recall what makes an expression a monomial. A monomial is a product of a numerical coefficient and variables with non-negative integer exponents. In our expression, we have the coefficient 4 and the variables x with exponent 2, a with exponent 1, and y with exponent 1/2. For an expression to be a monomial, all exponents must be non-negative integers. Since the exponent of y is 1/2, which is not an integer, this is not a monomial. Let's now determine the coefficient and the degree with respect to each variable. The coefficient is the numerical factor in the expression, which is 4. Now, let's find the degree with respect to each variable. The degree with respect to x is 2. The degree with respect to it is 1. The degree with respect to y is 1/2. Welcome to this math lesson. Today, we'll learn how to identify monomials, determine their coefficients, and find the degree with respect to each variable. Let's begin with an example. We have -4/5 times x times y times z. Let's identify if this is a monomial, determine its coefficient, and find the degree with respect to each variable. Let's first recall what a monomial is. A monomial is a product of a constant and variables with non-negative integer exponents. The coefficient is the numerical factor, and the degree with respect to a variable is the exponent of that variable. Step 1. Let's rewrite our expression in exponent form. The expression -4/5 x, y, z can be written as -4/5 times x to the power of 1 times y to the power of 1 times z to the power of 1. Quick challenge. Can you predict which exponents appear in our expression? Take a moment to write down your answer before we continue. Step 2. Now, let's determine if our expression is actually a monomial. For an expression to be a monomial, all variable exponents must be non-negative integers. In our case, each variable has an exponent of 1, which is a positive integer. Therefore, our expression is indeed a monomial. Step 3. Let's identify the coefficient of our monomial. The coefficient is the numerical factor in the expression. In our case, the coefficient is -4/5. Quick challenge. What do you think is the degree with respect to each variable? Take a moment to write down your answer before we continue. Step 4. Finally, let's determine the degree with respect to each variable. The degree with respect to a variable is the exponent of that variable in the monomial. In our expression, x has an exponent of 1, y has an exponent of 1, and z has an exponent of 1. Therefore, the degree with respect to x is 1, the degree with respect to y is 1, and the degree with respect to z is 1. Let's summarize what we've learned. The expression -4/5 x, y, z is a monomial with coefficient -4/5. The degree with respect to x is 1, the degree with respect to y is 1, and the degree with respect to z is 1. We also call the total degree of a monomial the sum of all variable exponents, which in this case is 1 + 1 + 1 is equal to 3. Let's look at the example shown here. We need to determine if this expression is a monomial and identify its coefficient and degrees with respect to each variable. The expression we're looking at is x squared y z cubed divided by 2. First, let's determine if this expression is a monomial. A monomial is an expression that can be written as a product of a numerical coefficient and variables raised to non-negative integer powers. We can rewrite our expression as 1/2 times x squared times y times z cubed. Looking at our expression, we can see that the numerical coefficient is 1/2, which is a valid coefficient for a monomial. The exponent of x is 2, which is a positive integer. The exponent of y is 1, which is a positive integer. Note that when no exponent is shown, it's understood to be 1. And the exponent of z is 3, which is also a positive integer. Since all variables have non-negative integer exponents, this expression is indeed a monomial. Now let's summarize our findings. The expression x squared y z cubed divided by 2 is a monomial. Its numerical coefficient is 1/2. The degree with respect to x is 2. The degree with respect to y is 1. And the degree with respect to z is 3. Additionally, we can find the total degree of this monomial by adding up all the exponents. 2 + 1 + 3 is equal to 6. In this video, we'll learn how to analyze monomials, identify their coefficients, and determine the degrees of each variable. Let's start by understanding what a monomial is. A monomial is an algebraic expression that consists of one term. It's typically written as a coefficient multiplied by variables raised to non-negative integer powers. For any monomial, we can identify, first, the numerical coefficient, which is the number multiplying the variables. Second, the degree of each variable, which is its exponent. And third, the total degree, which is the sum of all the variable exponents. Now, let's analyze our first example. Here we have the expression 5x squared y cubed z. This is a monomial because it consists of just one term. Let's first identify the numerical coefficient. The coefficient is the numerical factor, which in this case is 5. Next, let's determine the degree of each variable. For x, the exponent is 2, so the degree of x is 2. For y, the exponent is 3, so the degree of y is 3. For z, the exponent is 1, which is usually not written, so the degree of z is 1. Any other variable not present would have a degree of 0. Finally, we calculate the total degree of the monomial. The total degree is the sum of all the individual variable degrees. So for our expression, it's 2 + 3 + 1, which equals 6. Let's move on to our second example. Here we have the expression 4x squared y. This is also a monomial with just one term. Again, let's identify the numerical coefficient. The coefficient here is 4. Now, let's determine the degree of each variable. For x, the exponent is 2, so the degree of x is 2. For y, the exponent is 1, which is not written, so the degree of y is 1. Note that z doesn't appear in this expression, so its degree is 0. Finally, we calculate the total degree of the monomial. The total degree is the sum of the exponents, which is 2 plus 1, which equals 3. Let's compare our two examples side by side. The first monomial, 5x squared y cubed z, has a coefficient of 5 and a total degree of 6. The second monomial, 4x squared y, has a coefficient of 4 and a total degree of 3. The degree of a monomial helps us understand its behavior in algebraic operations and is especially important when working with polynomials. To summarize what we've learned, a monomial is an expression with exactly one term, consisting of a coefficient and variables with exponents. The degree of a variable is its exponent in the monomial. The total degree is the sum of all variable exponents. And if a variable is not present in the monomial, its degree is 0. Understanding monomials and their degrees is fundamental to working with more complex algebraic expressions like polynomials. Thanks for watching. Let's start with our first example. We need to determine if the given expression is a monomial, identify its numerical coefficient, and determine its degree with respect to each variable. First, let's recall what a monomial is. A monomial is a product of a number and variables with non-negative integer exponents. Let's analyze our expression 5, y to the power of negative 1 times x. We can rewrite our expression to better understand it. 5y to the power of negative 1 times x equals 5x divided by y. Now we can see that this expression has a negative exponent for the variable y. Since monomials must have non-negative integer exponents, this expression is not a monomial. However, we can still identify the numerical coefficient and the degrees with respect to each variable. The numerical coefficient is the number multiplier in the expression. In our expression, 5y to the power of negative 1 times x, the numerical coefficient is 5. Now, let's determine the degree with respect to each variable. The degree of a variable in a monomial is the exponent of that variable. In our expression, the degree with respect to x is 1, since x appears with an exponent of 1. The degree with respect to y is negative 1, since y appears with an exponent of negative 1. So for our first example, we have determined that 5y to the power of negative 1 times x is not a monomial due to the negative exponent. Its numerical coefficient is 5, the degree with respect to x is 1, and the degree with respect to y is negative 1. Let's move on to our second example. In this example, we need to determine if the expression 2 square root of 2 times x times y is a monomial, identify its numerical coefficient, and determine its degrees. Let's analyze this expression according to our definition of a monomial. The expression 2 square root of 2 times x times y consists of a numerical coefficient multiplied by variables with positive integer exponents. Both x and y have implicit exponents of 1. Now, let's identify the numerical coefficient. The numerical coefficient is 2 square root of 2, which can be written as 2 times the square root of 2. Finally, let's determine the degrees with respect to each variable. The degree with respect to x is 1, since x appears with an exponent of 1. Similarly, the degree with respect to y is also 1. So for our second example, we have determined that 2 square root of 2 times x times y is a monomial. Its numerical coefficient is 2 square root of 2, and the degree with respect to both x and y is 1. In this example, we're given the expression a equals 2 times x squared times y cubed times z times x cubed times 3 over 2 times y to the 5th power. Our task is to find the numerical coefficient and determine the degree of this with respect to each variable and its total degree. Let's start by simplifying this expression. First, we'll combine like terms. We have x squared and x cubed, which we can combine to get x to the 5th power. Similarly, we have y cubed and y to the 5th power, which gives us y to the 8th power. For the coefficients, we multiply 2 by 3 over 2, which equals 3. Now that we've simplified our expression, let's find the degree of the respect to each variable. For variable x, the exponent is 5, so the degree with respect to x is 5. For variable y, the exponent is 8, so the degree with respect to y is 8. For variable z, there is no explicit exponent, which means it's raised to the power of 1, so the degree with respect to z is 1. The total degree of a polynomial is the sum of the degrees of all variables. In our case, we add 5 plus 8 plus 1, which equals 14. Let's look at our example. We need to find the numerical coefficient and degree of the following expression with respect to all variables. Step 1. Let's regroup and organize the terms to make our calculation easier. First, I'll group the numerical coefficients together, and then group each variable with its respective powers. So we have 12 times 3 over 4 times 2, which we'll calculate in a moment. Then we have a to the power of 7 times a to the power of 5. Next, b to the power of 2 times b to the power of 2 times b to the power of 4. And finally, c to the power of 4 times c to the power of 6. For clarity, I'll rearrange this using parentheses to separate the numerical part from the variables. Quick challenge, can you predict the next step? How would you combine the numerical coefficients and the powers of each variable? Take a moment to write down your answer before we continue. Step 2. Let's calculate the numerical coefficient. We have 12 times 3 over 4 times 2. First, let's multiply the numerators. 12 times 3 equals 36. Then multiply by 236 times 2 equals 72. Finally, divide by 4. 72 divided by 4 equals 18. So our numerical coefficient is 18. Step 3. Now, let's apply the law of exponents to combine the variables. When multiplying terms with the same base, we add the exponents. For variable a, we have a to the power of 7 times a to the power of 5, which equals a to the power of 12. For variable b, we have b to the power of 2 times b to the power of 2 times b to the power of 4, which equals b to the power of 8. For variable c, we have c to the power of 4 times c to the power of 6, which equals c to the power of 10. Step 4. Now we can combine all our results into the final expression. Our numerical coefficient is 18, and for the variables we have a to the power of 12, b to the power of 8, and c to the power of 10. Therefore, our simplified expression is 18a to the power of 12 times b to the power of 8 times c to the power of 10. Step 5. Now, let's identify the degree with respect to each variable. The degree of a variable in an expression is the highest power to which the variable is raised. For variable a, the degree is 12. For variable b, the degree is 8. For variable c, the degree is 10. Step 6. Finally, let's calculate the total degree of the expression. The total degree is the sum of the degrees of all variables. So, we add the degrees of a, b, and c. 12 plus 8 plus 10 equals 30. Therefore, the degree of b with respect to all variables is 30. To summarize our results, the numerical coefficient of the expression is 18. The degree of b with respect to a is 12. The degree of b with respect to b is 8. The degree of b with respect to c is 10. And the total degree of b with respect to all variables is 30. Thank you for watching this Math GPT video on algebraic expression simplification. We learned how to find the numerical coefficient and the degree of an expression with respect to different variables. Remember to apply the law of exponents when multiplying terms with the same base, and calculate the total degree by summing the individual degrees of all variables. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.